Hello, my name is Gage, and this is Mark Guzdial. He does research at the University of Michigan. How are you today?
I'm doing well, Gage. Thanks for having me.
Awesome. So, just to start off, what do you want to tell us a little bit about what your research in computer science education is like?
Sure. So I've done a bunch of different things over the years. I'm actually a U of M graduate. I have a joint PhD in education and computer science. But then I went to Georgia Tech for 25 years and just got back to Michigan in 2018. Um, I'm probably best known for a class that I created called Introduction to Media Computation. We designed it at Georgia Tech for liberal arts, architecture, design, business, and management majors as a way of learning computing for communication rather than calculation. So we taught students how to manipulate pixels in a picture, samples in a sound, frames in a video to implement things like Snapchat filters or reverse and change the frequency of sounds or echoes or things like that, or to digital video special effects. From 2006 to 2018, I had two big projects, one called Georgia Computes, where we tried to improve computing education across the entire state of Georgia. And then I was part of ESEP, the Expanding Computing Education Pathways Alliance, where we worked with 16 states and Puerto Rico to improve things like how do you certify teachers? How do you train teachers? What do computer science classes count for? How do you measure participation in computer in your state? Um, I've done a bunch of laboratory experiments. I just had a student graduate last Wednesday. Woot, woot, woot.
Awesome.
Dr. Katie Cunningham just defended her dissertation, where she developed a way of teaching programming for students who don't actually want to become software engineers, but they want to be able to program, say, for data science. They want to be able to compose programs, but they don't really care about individual lines of code. They're not willing to trace code. And so she invented something called purpose first programming and then tested it in laboratory conditions and found that in 30 minutes of instruction, students afterward were able to write beautiful soup code to scrape websites.
Oh wow.
Um, so I do a bunch of stuff in equity and broadening participation in computing,
Mhm.
and I have student. My big focus at Michigan now is that I'm interested in trying to put computing, explicitly programming activities, into non-CS classes. So
Really?
I have two students, Bahari Namipur and Tamara Nelson From, who are working on ways of putting programming into history courses.
Oh wow.
Um, because it turns out that if you really want CS for all, you want to reach everybody, you got
Hmm.
to go where everybody is. For the most part, less than 10% of US students ever enter a computer science course.
Oh wow.
Uh, and the difference between AP Computer Science and AP US History for minorities, for members of underrepresented groups, is absolutely stunning.
Hmm.
There are 6 times more Black students taking AP US History than AP Computer Science, and 14 times more students who are Latino Latina than in AP Computer Science.
Oh wow.
So history is a place to reach everybody. So if I can put programming activities into history class, I give everybody a chance to discover that they could be good at this and they don't have to be afraid of this.
That's awesome. So I think that's really cool that you're able to find a way to take computer science and put it in like history, which is you never think about that comparison. So could you maybe go into a little bit more detail about what kind of activities they might be doing with like programming and computer science in like a history class?
Sure. So I'm working with Tammy Schreiner, who is a social studies education researcher at Grand Valley State, and she teaches a class, data literacy for social studies teachers. So she's been able to show in her research that data literacy is really increasingly important in social studies classes. Most of the 50 states require students to be able to reason about data and to be able to interpret graphs, timelines, maps, things like that in their social studies classes. Um, but social studies teachers aren't necessarily taught how to do that. And we started collaborating when I first got here in 2018 um, because she'd like teachers to be able to make their own visualizations and
Hmm.
they'd like their students to build their own visualizations. But most tools aren't really designed for social studies teachers.
Hmm.
I mean, somebody becomes a social studies teacher often because in comparison to they don't really want to be a math teacher or a science
Yeah.
teacher or work with data or work with computers. So we've been building tools explicitly for social studies teachers. We do what's called design. We take tools, put them in front of teachers, and have them say, "Oh, I see what you're doing. Yeah, that's really terrible. Let me tell you what I'd really use." And then we build new tools. So we currently have a visualization tool that teachers can use. Like, one of the insights is that for a history class, you never want one visualization.
Hmm.
An interesting history problem is where you have two visualizations that contradict.
Yeah.
So if you look at the population of Rwanda from 1800 forward versus the population of, say, Angola or Congo, you will see that Rwanda had this big dip in the late 1990s, early 2000s. Why? Well, it was the Rwanda genocide.
Hmm.
But by looking at these comparisons, students can come up with an understanding. Wow, something strange happened in Rwanda. How do we investigate that further? So in our tool, students are building data visualizations. And if you click on a visualization, I'll actually show you a little bit of programming notation that describes how that graph was built. It's not a program you can manipulate, but it's a program that describes what that graph is.
Hmm.
We have then built a second version of the code of the system where you can manipulate the visualization using pull-down menus or by editing the code. And those are multiple linked. So if you change the drop-down menu, I'll change the code. If you change the code, I'll change the drop-down menu. And both of them change the graph.
Okay.
So we're trying to create a smooth transition from being able to specify a visualization into coding.
Ah, okay. So this it's like a transition. So like they can first they know how this visualization works, and then now we can figure out what kind of code is going into that, and that's like a building block.
Right.
That's awesome.
Exactly right. That's really nice. Yeah.
All right.
We have a second project where we're trying to support building timelines.
Hmm.
And it's getting us to think about something really interesting. There are existing tools for timelines where you specify the timelines in things like spreadsheets. Here's all the events. And teachers actually find them very difficult to use. We're now having them create event objects, which will then create a timeline.
Hmm.
And the teachers so far in our code design activities, they like that a lot, which sort of raises an interesting question. Why would event objects be easier to understand than a spreadsheet view of the same events? That's one research question we're trying to explore.
Hmm.
And the second is we've come into a realization, something just about anybody who's done much with computing would realize, but most of our social studies teachers haven't. The notion of what we're calling an intermediate representation. Think about most people who ever use the web never see HTML. So this idea that the web is actually constructed from an intermediate representation that doesn't look like the final thing is a weird notion, right? Everything else we use, Word, Excel, PowerPoint, all of those, you manipulate the final thing. You manipulate the slides, you manipulate the document.
Hmm.
This idea that there is an intermediate representation, there are events which build a timeline. That's a computing idea that our teachers are not familiar with. And so we're able to explore ideas about what do you think a program is anyway, elementary level with these.
That's awesome. So now, I guess kind of like that, like you said, like the object of the timeline is like an event, and then it helps, and that's also like a direct way to relate back to computer science and computational thinking, because now we can take this object and we say, well, we build objects, do objects to build a timeline, and then we also use objects to build programs.
Exactly right.
That's
this
awesome.
idea, there's this wonderful work going on at the University of Chicago. Diana Franklin is the lead on it, where they've been looking at what are the core ideas of computing that you have to get, that all computer scientists just know, that you have to actually teach to K-8 kids. It isn't obvious. So like one of them is every time you run the program, if it doesn't accept any input, it will always do the same thing. That isn't obvious to students.
Yeah.
And the idea that a program is actually constructed out of maybe a large number of, but fairly small number of primitive things, right? There's for loops and conditionals and variables.
Yeah.
It's a very few number of things, bind them in lots of different ways to make programs. That idea that programs are constructed out of something else, these more primitive things, these objects, that's not the thing to K-8 teachers, or really K-8 students, or really anybody, right? Anybody who does programming has to first realize, oh, this program generates the output.
Yeah.
If you don't get that, You can't get very far.
Hmm.
We're trying to figure out how to teach that even in social studies classes.
That's awesome. So you kind of talked about this transition into like now we've used history to get to computer science. So now that we've gotten like these kids like interested in computer science, they've gotten a few more topics. Where do we go from there to make these computer science classes like really give the students the content they need? Like, what do they need to be learning at these classes to get them prepared for more difficult topics?
Which classes are you thinking about? K through 12, undergraduate?
This is more like secondary education, so like 9 through 12, like they're introductory computer science classes where they're really learning like the fundamentals of like programming and those kind of concepts.
So, I mean, hmm. So there are a bunch of state standards now
Hmm.
for what needs to be taught in primary and secondary school computer science.
Hmm.
Um, was a K through 12 CS framework. You can find that on the web, K through 12 CS framework, that sort of identifies those elements. What should everybody learn? Um, there's not empirical support for the things that they're claiming. And I'm interested in sort of doing the experiments that say, what are the low level computing ideas? Like this notion that programs are deterministic, this notion that programs are constructed out of something else in intermediate representation.
Hmm.
I'm exploring with another project the idea that the terms, the keywords in a program are actually relatively arbitrary. It doesn't have to be English words. It doesn't have to
Hmm.
be repeat, if, while, for. It could be other words. That's not obvious, even to
Hmm.
undergraduates in computer science. These are the kinds of things that I'm interested in teaching at these lower levels. So there are a set of standards. You can find lists out there what everybody ought to know. Um,
Hmm.
I'm not. I've really shifted my research away from trying to focus on computer science classes themselves. I mean, still am doing work in that space. I have a student who's doing fabulous work with understanding the spatial metaphors used in teaching computer science.
Hmm.
Um, when people talk about going up or down or left or right, there are no directions in the computer. What are you saying?
Yeah.
But people do,
Hmm.
right?
Yeah.
Every teacher has at some point said in the class, okay, now we're at this line in the code. Really? What does it mean to be at a line in the
Hmm.
code? You physically jump inside the program? Um, anyway, so all of that set aside, what really drove my current research direction is my work in ESEP, Expanding Computing Education Pathways.
Hmm.
Um, there is no state in the union where more than 10% of the high school students take computer science.
Oh wow.
In most states, it is now around 40 to 50% of the high schools offer computer science. So, like in California, it's around 43% offer computer science, and it's less than 4% of the kids take computer science.
Less than 4%.
Computer science is scary.
Hmm.
People don't want to walk into a computer science class. How do we change that? I'm interested in making computer science more welcoming by
Hmm.
putting it into other, by putting it into history class, by making it so that students see programming and programs earlier so they can
Hmm.
develop a sense of self-efficacy. So maybe that encourages more people to try out computer science.
Hmm.
So that's where I'm at. I'm trying to say, how do I convey to people what programs and programming, what programs are, what programming is as an activity, so that students are willing to do it?
Hmm.
Now, how to change computer science classes to make them better, that's, we could go on for a very long time on that. Um, a lot of the research, I mean, that's what Katie Cunningham's research was about in
Hmm.
part. Um, a big part of what we know of the last 5 years has really shown us that the biggest issue in people learning computer science is emotional. They get frustrated. The
Hmm.
programs are too hard, or they're ill defined, or the teacher makes them feel like they don't belong. It
Hmm.
turns out that most people, there's a technical term in the educational psychology world called self-efficacy. Their sense that they can do something.
Hmm.
Um, you probably have high self-efficacy in your ability to ride a bike because you've ridden a bike before.
Yeah.
That's high self-efficacy. Most people's self-efficacy about programming is lower when they leave the class than when they enter the class.
Oh wow.
Yeah, programming actually beats people down. How do we change that? How do we change it so that people leave the intro class more confident than they were going? That to me is like the biggest challenge that we have right now based on the
Hmm.
research of the last 5 years or so.
So you talked about how we need to make the computer science like a less scary idea. So when do you think, like, how early should we be teaching these kids, like even just the simplest computer science ideas?
Yeah, it's a really good question. And as I've been doing research in K through 12, well, mostly middle school and high school in the last few years, um, I've realized that I know less about the answer to that question than I used to.
Hmm.
I used to say, it's not clear that we can teach programming before around the age of 12 because Jean Piaget, he was a cognitive psychologist who made the argument that he called himself an epistemologist, that people, people develop abstract reasoning skills around the age of 12, and that you really can't program without abstract
Without that.
reasoning skills.
Hmm.
But there's been other work since then that show that even younger kids might be able to do some forms of programming, like the K through 8 work that Diana Franklin's doing.
Hmm.
Um, but now, in August we had our first session with our social studies tools with practicing social study teachers. We had both middle school and high school teachers. And we had this one tool, we put it in front of the teachers, and the high school teachers say, "Oh, sure, my seniors could do that. That's not a problem." And then the sixth grade teachers say, "No way, my students couldn't do this at all." And it really had not hit me before. It's obvious in retrospect. Do you know
Hmm.
there's a big difference between an 11-year-old and a 17-year-old,
Oh yeah, a very
right?
big gap there.
Yeah. So I now realize that it doesn't even have to do with sort of programming in the general sense as an abstract specification of process. Things like closing quotes and curly braces and semicolons. Seniors might be able to deal with that, and the 11-year-olds might not.
Hmm.
So it might be that we can make programming work at younger ages if we have better tools. So I don't have a good answer to that. It's something that
Hmm.
I'm continually thinking about, trying to figure out what will work. I've been focusing mostly in the years that I've been here at Michigan on teachers because there's a bunch of research
Hmm.
that show that students are willing to do things that teachers are not. Um, and teachers are the gatekeepers for the class. If the teacher
Hmm.
isn't willing to do something, it'll never enter the class. So by focusing on teachers first, I have a better shot at creating things that will actually be adopted and put into classrooms.
When I was researching, I found that a lot of issues stem from teachers are like struggling to teach their class. They don't have many tools available to them to help them teach their class. So, what can we do to help these teachers get more prepared to teach like computer science, maybe in it doesn't have to be a computer science class, but also be like their history class. How can we prepare them more, make them more willing to use this and more understanding of computer science ideas?
A really hard problem.
Hmm.
Um, okay, so there is actually a lot of curriculum, a lot of lesson plans, curricular materials, classroom materials for computer science classes today. Code.org has produced a ton. That's really
Hmm.
great. There's another issue though, and there's also things like Exploring CS, exploringcs.org, really terrific materials. Um, the problem is, how do you help teachers to be willing to teach this and to feel confident in it?
Hmm.
And how do you motivate teachers to get trained in this space? This is how where things like teacher credentials come into play. Um, you can offer teachers a certification. I will certify you as a computer science teacher. That can be a motivation for teachers because then their resume is more valuable. They might be able to get other kinds of jobs, more interesting jobs.
Hmm.
But if you make it too hard to get that certification, nobody's willing to do it. We built a certification in Georgia, which was not required of anybody.
Hmm.
Cost the students, they actually had to take like 5 computer science classes. And over the space of like 6 years, I think maybe 3 people ever got it.
Oh wow,
It was just too hard.
too difficult.
There's a big program in Boston called, now I'm going to suddenly blank. It's about generally producing STEM, but in like 15 years, they had only 2 people become computer science teachers.
Oh wow.
Um, yeah, it's like, it's crazy hard to become a computer science teacher. I had a student, Li Jung Ni, who studied exactly that. How
Hmm.
a teacher decide to become a computer science teacher. So um, the problem is less about materials and more about motivating teachers. more about preparing teachers and
Mm-hmm.
also trying to create jobs for teachers. Um,
Mm-hmm.
I had a student who graduated last December, Miranda Parker. She's now a postdoc at University of California at Irvine, um, who asked the question, um, how do high schools decide whether or not to offer computer science? And if you talk to principals, which she did, she talked to principals, talked to people who are making these sorts of decisions,
Mm-hmm.
she found that they will tell you, oh, there's not that many computer science teachers available. But then you dig a little bit deeper, it's not that easy. They have to make choices, right? You got to here. It's not just computer science money, it's money for people. Where's the best place to put that money into your school and make it useful?
Mm-hmm.
So she talked to this high school principal who said, okay, I could take a teacher and have them teach computer science, but then I got to fill their class and I could fill that class with this one. And in the end, they got to, okay, I can offer computer science or I can offer choir.
Oh, wow.
And I don't know if anybody will take computer science.
Mm-hmm.
My choir class is completely full and the students need the credit hours to graduate.
Mm-hmm.
From a principal's perspective, it's a no brainer which one you offer.
Mm-hmm. So he obviously takes the choir class there.
Exactly. So it's not so simple that we just need more computer science teachers or better trained computer science teachers.
Mm-hmm.
Demand for computer science teachers. We have to figure out how to prepare computer science teachers.
Yeah.
So it's a pretty complicated system to try to grow computer science in high schools.
Yeah, that does seem like a complicated problem. We have no demand, so no one wants to go into it. But then no one wants to go into it, so we have no interest in getting
Supply.
one. Yep, no supply.
And it's not no demand. I mean, like I said, 40% of high schools are offering computer science now,
Mm-hmm.
but it's low demand. There's not a lot of to increase the number of computer science classes, and particularly with very few students taking these classes, it's like, well, what principal then wants to offer it?
Okay. For our final question, can you tell us a bit about your research in curriculum and what we should be teaching in classes?
Sure. I mean, we built the media computation course in 2002. And then in 2012, I did a paper where I reviewed the 10 years worth of data that we had on it. And, so what happened was that at Georgia Tech, everyone is required to take a course in computer science.
Oh, wow.
And for the first 4 years that we had this requirement from 1999 to 2003, the pass rate was around 78%, which sounds really good. But then you realize that the majority of the students in those classes were science and engineering majors.
Mm-hmm.
We looked at liberal arts, architecture, business management. The pass rate was around 50%. Only about half the students graduated, were retained in the class per semester. So that's why I built the media computation class. And then at Georgia Tech, the pass rate went from, like I said, that it was around 50% to around 85%. And it stayed 85% for the next 10 years. I mean, it was never lower than 85%. We sometimes pass as many as 90% of the students. So, and then we did a bunch of studies about why did media computation work? And what we found was that students found it to be relevant. Gage, what's your major?
I'm doing computer science myself. That's what I'm studying.
So you've taken 183, 101. What have you taken?
I got AP credit. I took AP CSA my senior year of high school.
That's great. AP CSA. Did you do the picture lab?
I don't believe so, actually.
Picture lab is one of the exemplary labs that they have for AP CSA. It's where you manipulate pixels of a picture. It was done by my my research partner and wife, who wrote the media computation books with me. I'm going to bet that a lot of the times you did problems in AP CSA, which seemed like, why would I care what the maximum value in this array is? Or why would I want to find the longest substring with repeated characters in this string? These are common problems that you have in intro computer science class. And students find them totally ridiculous. Why would I care about that? Media computation made the class more relevant, and the relevance led to greater interest, and the greater interest led to greater retention. That's what our research showed.
I got you. So, like, when they're able to apply it to say, hey, this is something I could use in my career, or something, it's like, that's what I want to do. That's what got them interested. That's what got them engaged with the course.
Well, it's relevance, which
Mm-hmm.
might be about their career, but it might just
Yeah.
be, hey, this is cool. Oh, I
Yeah.
like doing this, right? Very
Mm-hmm.
few people. I am so excited about finding the longest substring of repeated
Yeah.
characters in this string,
Mm-hmm.
right? But hey, this is how images get negated. And this is how pictures go from color to sepia toned.
Mm-hmm.
Oh, that's kind of cool.
Yeah.
If you say, hey, that's kind of cool, that's a sense of relevance.
Mm-hmm. So it's like the hands-on experience with this is what computer science can do, and this is what's happening when I do these things. It's that understanding that helps people get encouraged to learn more.
That's right. Yep.
That's awesome. Well, I think that's all the time we got. So thank you so much.
My pleasure. Thanks for having me.
No problem.
Okay. Bye-bye.